The term meteor is used to refer to any object in space that ranges in size from a dust particle to the size of an asteroid. Based on this definition, approximately 4 billion meteors fall to Earth daily, but most of them are small stones that completely burn up upon entering the atmosphere, while some manage to penetrate and reach the Earth's surface. Welcome to the Random Question channel. In this episode, we'll answer the question, what if a meteor hit Earth at the speed of light? First, let's break down the topic step by step. Imagine a meteor made of a strong element like diamond with a diameter of just 30 meters. Let's assume it's heading toward Earth at a speed of about 3,000 kilometers per second, which is 1% of the speed of light. In this case, upon reaching the atmosphere, a violent reaction will occur, generating immense heat similar to that of nuclear reactions. If this meteor manages to keep its structure and penetrate the atmosphere, it would strike the Earth's surface with energy 1,000 times greater than the most powerful nuclear weapon ever known in history. The result would be as if life never existed in that place at all. This scenario is the result of a collision with an object moving at 1% of the speed of light. But if we increase the speed to 99% of the speed of light, the bonds holding the meteor's molecules together would fail to maintain their cohesion, and the meteor would turn into a cluster of carbon atoms, moving at an incredible speed. As the laws of physics dictate, the higher the speed of an object, the greater its kinetic energy. Let's imagine what would happen next. With such an immense speed, when the meteor is in the air, the situation would be entirely different. Air would enter between the carbon atoms and get trapped inside them, leading to a significant increase in the meteor's size. But once it reaches Earth, it would disintegrate again. And this time, due to the massive expansion, it would penetrate the Earth with an explosion 50 times more powerful than the meteor that caused the extinction of the dinosaurs. This force would be sufficient to wipe out all life on Earth. If we increase the speed to 99.99999%, the energy per carbon atom would increase, and the meteor's size would become almost as large as the Moon. Upon impacting Earth, it would cause a massive crater in the Earth's crust, and the ground would experience powerful tremors that could lead to the complete melting of the Earth. If we increase the speed to the number displayed in front of you, which is the highest speed recorded for a mass-bearing particle, one possibility suggests that as soon as the meteor reaches Earth, a massive cloud of plasma, radiation, and particles resulting from the explosion would spread across the entire surface of the Earth. In less than 40 milliseconds, the Earth's temperature would rise entirely, producing light brighter than the sun itself, assuming the planet remains intact, that is. And all this without even reaching 100% of the speed of light. And with that, we've answered today's question. What if a meteor hit Earth at the speed of light? See you next video.